my Ninja Warriors. Welcome to yet another power packed session. I am Namrata, your mathematics expert, and we are doing relations and functions for your upcoming CBSE board examinations. If I am perfectly visible and audible to you, do let me know in the chat box so that we can further proceed with the session. All right, so I have already seen the comment section. So there is a lot of confusion that what is going to happen in this session. So basically we are going from scratch. We are going to study all the concept along with important questions. Yes. So relations and functions, important concepts, all concepts basically, and the most expected questions which you can see in your upcoming board examination 2024, right? So in the chat box, am I audible? Am I visible? Yes, I can see chat box. I can see comments pouring in. Okay, so it's not gonna be a very long session. We'll try to finish this session before, like, within 1.5 hours. So yes, it is going to be really short session. Hashtag mission 80 on 80 in the chat box. All right, I can see Grai Finder, I can see Mohammed, I can see Stains. Keep joining, keep coming, keep liking the session, keep sharing the session. All right. So I already told you 1.5 hours plus minus 10-15 minutes. Okay, keep liking, keep sharing so that we can expect maximum interaction, maximum doubt solving in this session. Okay, completely from scratch. Yes, this session is completely from scratch, and we'll study all the concept and PYQs plus important questions as well. So without any further ado, let's get straight to our topic, which is relation. Now, before starting with relation, I have to tell you something. Before starting with this relations, Cartesian product of sets is something you should know. You should be knowing. Right? So you can see I am starting even before the relations part, right? So if you have not studied anything, then this session is also for you, right? So Cartesian product of sets. So suppose you are given with two different sets. You can see capital A, capital B. Two sets are here. Okay, and these two are non-empty sets. Non-empty sets. Now, the set of all ordered pairs A, B is called Cartesian product of set A and set B. So, this is the language. I'll explain you what I'm trying to say. So, suppose you have A cross B. Cartesian product of two sets is denoted by this symbol, which is A cross B. Now, what is Cartesian product? Suppose you have two sets given. Set A is A, B, C. Set B is 1, 2, right? Now, if you need to write A cross B, that is Cartesian product. So this is also a set which will have all the ordered pairs, where in the ordered pair, first element will be from set A and second element will be from set B. Suppose A, 1, right? So A, 1 will sit inside your A cross B. This is your first ordered pair, comma. A, 2, right? Sorry, it's a comma. Eraser, yes. A, 2. Right, so A, 2 is another ordered pair. Tell me in the chat box what other ordered pairs you can expect. So B, 1 and B, 2. So B, 1 and B, 2. Then we have C, 1 and C, 2. Right, C, 2. Eraser. And yes, C, 2, bracket close, curly bracket close, right? So this is your A cross B. So A cross B is having set of all ordered pairs, in which the very first element of the ordered pair will be from set A and the second element will be from set B. So this is all about A cross B. Now, one thing very important to notice, that number of elements of set A. Who is going to tell me? In here you can see 3 elements are there in set A, right? And 3 elements you can clearly, 2 elements you can see clearly in set B, right? Now, how many elements are there in A cross B? Who is going to tell me? How many elements in A cross B? So, in A cross B, I can clearly see that, yes, A cross B, 1, 2, 3, 4, 5, 6. 6 elements. So how to create a formula? Can you see 3 2s are 6? That means we got a formula. If cardinality means what? Number of elements of set A. If cardinality of set A is P, suppose cardinality of set B is Q, then cardinality of A cross B will be what? P cross Q, right? This is the very first formula which I would like to tell you, right? Yes. So this is the thing, okay? Let me just remove some of the text. So this is the formula, this is the key point which you need to note down, that number of elements in Cartesian product of sets will be equal to what? P cross Q. Yes, P cross Q. Let me just remove it. So can you see, if cardinality of A is P, cardinality of B is Q, then cardinality of A cross B is what? P cross Q, right? So number of elements in A cross B we can clearly say is 3 cross 2, that is 6. And this I have already written down, A comma 1, A comma 2, right? A comma 2. Then B comma 1, B comma 2. Then C comma 1 and C comma 2, comma 2. Right, curly bracket close, 6 elements, 1, 2, 3, 4, 5, 6, right? Okay. Now, what is relation, ma'am? Why are you teaching us Cartesian product? What is relation? What is the relation between your relation and Cartesian product? So, let me just reveal the definition of relation now. You will understand it better. So, a relation, suppose you have two sets, A and B, right? Then a relation R is nothing but subset of A cross B. Yes. So now you have seen already, na? A cross B you have already seen. Now the moment you write the subset of A cross B, any subset, there are multiple subsets of A cross B, right? You can just write A comma 1, you can just write 2 ordered pairs, you can just write any 3 ordered pairs, you can just write all the ordered pairs. So there are multiple subsets of A cross B. Any subset is called as relation. So relation is nothing but what? Subset of this A cross B. This is very, very important. Okay. All right. So relation is nothing but subset of A cross B. Okay. So let me just show you. Let me just tell you. So one relation, one kind of relation of A cross B. So suppose 3 elements in A and 4 elements in B. So one type of relation is, suppose first element is connected to first element. That means, let us suppose this is A, B, C. This is 1, 2, 3, 4, right? Now relation will be what? Only A comma 1. Because A comma 1 is what? Subset of your A cross B. This is your relation 1. How many relations are possible? So basically over here, A comma 1, right? And A comma 1, A comma 2. A comma 2, right? Yes. So this is all about multiple relations can be formed. So let me just take you one particular scenario over here. Let me just take one scenario. Yes. Let me just take one scenario so that you understand me better, understand this better. Let us suppose you have set A 1, 2 and set B is what? A. Right? Now A cross B, who is going to tell me? So A cross B, I am taking a simple example. A cross B will have 1, A and 2, A. That's it. Right? Now, what are the subsets of A cross B? Who is going to tell me subsets of A cross B? Subsets of A cross B will be, so first subset will be 5. Right? Where nothing is connected to, no one is connected to nothing. Right? Second will be what? R will be, so subset will be equal to subset I am writing now 1, A inside the curly bracket. Third will be 2, A inside the curly bracket. Fourth will be 1, A and 2, A, both are there inside your curly bracket. So 4 subsets total are possible. 4 subsets total are possible. That means 4 types of relations are possible. Relation number 1, where no element of set A is connected to no element of set B. This is relation number 1. Relation number 2, which is possible, that only first element 1 is connected to, so this is nothing, okay? So 1 is connected to A, this is one of the relations. Second is, now this is not connected, 2 is connected to A, this is the second relation. And third relation, sorry, fourth relation. So basically fourth relation will be 1 is also connected to A, 2 is also connected to A. These kind of 4 relations are possible. Okay, all right, yes. So what does that mean? What does that mean? What does that simply mean? Can I say one thing, that if you have two sets A and B, then number of relations will be equal to number of subsets of A cross B, right? The number of subsets you are able to form, as many relations you will be able to form, right? So number of relations is nothing but number of subset of A cross B. Now a cardinality of A if given as P, cardinality of B is given as Q, then you know what, cardinality of A cross B will be what? PQ. And number of subsets of any set is what? 2 raised to power cardinality of that set. So number of subsets of A cross B will be 2 to the power PQ, and this will be equal to number of relations. Number of relations, right? So over here, if we have 6 element in A, 4 element in B, total number of relations that can be formed out of A and B will be equals to 2 raised to power 6 into 4. So that is 2 raised to power 24, right? So this is nothing but the basic of your relations. Let's get into more details. Let's study about what are the types of relations, right? Okay, and what are the terms related to relation? So the very first term related to relation is domain and of course range. So now you'll be acquainted with the term domain and range, but in relation there is a slight change. So can you see this example? If you have set A and if you have set B, right? If you have set A and B, and this relation R is defined as this. So this is how we write any relation. R is such that A comma B will sit inside this relation R. Listen to me carefully. This A comma B will sit inside the relation R if this condition is satisfied. What is this condition? B is equals to A square. And you know what? A is coming from set A, B is coming from set B, it is written. Right? So what we need to do is we need to write the relation R. We need to write its domain and its range as well. Right? So first of all, let me just write the relation. So R will be equal to, so the first ordered pair A comma B, we know that A comes from this set. So if your A is 1, if your small a is 1, right? So B will be what? B is equals to 1 square. If A is equals to 1, B is equals to 1 ka square. So 1 comma 1 is first ordered pair, right? Comma. The moment you put A is equals to 3, right? Your B will be what? 3 ka square, which is 9. So 3 comma 9 is another ordered pair. The moment you put A is equals to 5, your B will be 5 ka square, that is 25. Can you see all the second elements which we are getting now? 1 is there in set B. 9 is there in set B, right? So now 5 comma 25 will also be there. And next, the moment I put A is equals to 7, B will be 49, 7 ka square 49. But you know what? This 7 comma 49 will not sit inside. I need to close the bracket. This comma is useless. Why? Because 49 is not there in my set B. So no. I cannot make 7 comma 49 sit inside my relation. So this is all about my relation. My relation which is satisfying this condition is having only 3 elements. Unfortunately, 7 comma 49 is not there. Now what is domain? Domain is set of first component of coordinates of ordered pair of relation R. So basically first component. So domain of R will be equal to first element 1, 3 and 5. 1 comma 3 comma 5, right? Only first element which are sitting inside R. You may make a mistake that you can write, okay, complete set A is your domain in this. No, not at all. Only the first element which are sitting inside my relation, because we are talking about domain of relation. not the domain of the set, right? So this is domain of R and range of R. Range of R, same funda, same drill. The second element 1, 9 and 25. So 1, 9, 25 is the range of R. I hope you know by now you know everything about your domain and relation. Right? So I can see in the chat box. Yes, perfect. Let's move on thoda sa. Let's talk about types of relation. So the very first definition which is given in your NCERT is empty relation. Now what is empty relation? You know, a relation where no element from set A is connected with any element of set B. So a relation A is called a void or empty relation. क्या हो गया? Void or empty relation if no element of set A is related to any element of set A. Now one very important thing which basically many students don't know, very small thing. This term on set A, what does that mean? Who is going to tell me? On set A, what is the meaning of on set A? So the meaning of on set A is nothing but A cross A is the thing. That means your first set is A and your set B, which is the second set, is also A. That means A cross A is there, right? So relation is defined on set A. Both the set, first and second set, are A only. No difference, okay? So a relation on a set A, can you see this? A relation on set A is called void or empty relation if no element of set A is related to any element of set A. How do we write it? R is equals to null set. Can you see this? R is equals to null set. Okay, right? So suppose we have this example that A is equals to student in boys school. Students in boys school, right? So set A is having all the name of the students which are studying in a boys school, right? Now relation R is defined in such a way that A comma B will sit inside my relation where my B is sister of A, right? My B is sister of A. That means my B jo hai na, this should be a female, right? And A can be anything, right? A can be either male or female. So B should be female. And both A comma B belongs to A. And this B belongs to A. So any female should definitely belong to A. It can't be possible. If I tell you ki I have a group of boys and you know what? You have to write a ordered pair where over here this is your brother and this is your sister. So basically the sister is missing because we have a group of all boys and this brother and sister both are belonging to only one set, the boys set. So that's why this relation is null. Okay, all right, perfect. Yes, all right. Clear? Okay, who is saying A cross A is null set? No. A cross A is not null set in this case. Suppose we have A set as Raju, Farhan, sorry spelling ठीक कर लेना, and Ranchhod Das. Farhan and Rancho. Okay, so A cross A will have what? A cross A is not null set. So A cross A can have what? Raju comma Raju, Raju comma Farhan. But this relation has some condition. This relation is having condition that B should be sister of A, which is not possible. So A cross A is not null set, but relation R is a null set. Okay, all right. Let me move on to my next definition, which is universal set. Now universal set ekdam opposite, absolutely opposite to your empty set, right? So in here each element of क्या हो गया? Each element of set A is related to each element of set B, right? Set B is set A. So a relation which is defined on set A where each element of set A is related to every element of set A. Let us have a look. So your R relation will be A cross A. Let me just show you. So suppose you have A set as 1, 2, 3, right? So this is your 1, 2, 3 set A, and the next set is also 1, 2, 3. One is connected with 1, one is connected with 2 and 3. Now 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. All possibilities are there. So if you write 1 A cross A will have how many elements? So 1, 1, right? A cross A will have 1, 1 and 2, 2, 3, 3. Then we have all the elements 1, 2, 1, 3, right? 2, 1, 2, 3, 3, 1, 3, 3, 3, 2. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. And you know what? In the relation, all these elements will sit inside my relation. So relation R is equals to exactly same. That's why A cross A. All possible elements will sit inside my relation. Suppose we have this relation for an example. So A is set of real numbers. A will have some set of real numbers, and relation R will have such ordered pairs where the subtraction between two elements is non-negative. You know what? Modulus of any quantity is always non-negative. That means this statement is true for any A comma B. For any ordered pair, this statement will be true. You put anything inside this A comma B, this will be true. That means this condition will be true. That means all the ordered pairs will sit inside my relation. All the ordered pairs will sit inside my relation. That means each and every element of set A is related to each and every element of set A. That means this is a universal relation. Are you getting it? Okay. Yes. All right. Identity relation. Uchuk Puchuk, don't worry. We are not leaving JEE at all. Don't worry. Just 4 days we are dedicating to boards, and then we'll be jumping towards our JEE main only. Right? Yes. Do not worry about that. Okay. Okay, how long is this session? So I have told you multiple times. We'll be finishing the session within 1.5 hours, plus minus 15 minutes will be there. Okay, so identity relation. Now listen to me carefully, very carefully, word by word. Identity relation is such that if each and every element of set A is related to itself only. Let me just show you. So over here, yes, if you have 1, 2 and 3, 1, 2 and 3. So can you see to itself only? This keyword is very important. That means 1 is only related to 1. 1 cannot be related to 2. 1 is only related to 1. 2 is only related to 2. 3 is only related to 3. Right? So this relation R will have what? 1, 1, 2, 2, 3, 3. It cannot have any other ordered pair. Right? So both should be same. So over here, relation R, so all the ordered pairs will sit inside my relation R if A is equal to B. Only if A and B are equal, then only I can say that my ordered pair will sit inside my relation. I hope you're getting it. So identity relation is each and every element is related to itself only. Okay, all right. Identity, that means mirror. Okay, now we have a very important type of relation which will be definitely there in your board examination, which is reflexive relation, and this was there in your JEE main examination as well. So listen to this carefully, uchuk puchuk, for you also. Okay, so this is also for JEE. NCERT is related to your JEE only. We've got such questions in your JEE examination 2024. So this is important. Relation R on set A is said to be reflexive if every element of set A is related to itself. Now, can you see the only keyword is missing? For identity relation only was there, and it is each and every element of A is only is related to itself. What does that mean? That one should be related to 1. Okay, 2 should be related to 2, and 3 should be related to 3. So each and every element of set A is related to itself. And you know what? After that, if one wants to make a connection with 2, he is free to do that. But in identity connection, identity relation, it is not possible. In reflexive relation, one should be connected to one can be connected to any other element as well. So one can be connected to 2, one can be connected to 3, right? So let's consider, let's see the definition first. A relation R is reflexive if A comma A belongs to R for every A belongs to capital A, right? So let me just show you. We have 3 examples. We need to tell whether R1, R2, R3 are reflexive or not. So R1, okay, so we have set A 1, 2, 3. So if 1, 1, 2, 2 and 3, 3, these 3 are present in my relation, that means this is definitely my reflexive relation. What about R2 in the chat box? What about R2, right? So 1, 1 is there, all right. 2, 2 is there, but 3, 3 is not there. Oops, that's how I fail. So reflexive, it is not at all reflexive. Okay. So can you see 1, 1, 2, 2, 3, 3 was there, and apart from this, this 1, 2 is already present, but I am not bothering because my job is to see only these three ordered pairs. So that's how it is reflexive, right? And what about this? 1, 1, 2, 2, 3, 3 are present. That means that this relation is reflexive. Okay. Now out of R1 and R3, which one is identity? Out of R1 and R3, which one is identity relation? Who is going to tell me which one is identity? So basically 1, 2 is available over here, present over here. So this is not an identity, but this, because itself only, 1 is connected to itself, 2 is connected to itself, 3 is connected to itself only, and no other random ordered pairs are there. So that means this is identity also. And this is no chance of identity relation. So R3 is reflexive as well as identity relation, right? Okay. All right. So if I tell you one statement that every identity relation will definitely be reflexive relation, but not the converse. But not the converse. And you know what, Uchuk Puchuk, I am teaching this reflexive, symmetric, transitive in very detail, but in JEE we don't usually do that. We just go through it very quickly, because from this particular thing you will get +4 marks, I know. But in JEE we go through it very quickly because syllabus is vast. Okay. Yes. All right. So we have a question. Question says that a relation R is defined on set of natural numbers. Okay. And R is equals to A comma B, A divides B. We need to figure out whether my relation is reflexive or not. Figure out my relation is reflexive or not. Okay. So for a relation to be reflexive, likho. For a relation to be reflexive, what is the condition of reflexive? For a relation to be, you have to write in your basically board examination. For a relation to be reflexive, right? R should be having ordered pair A comma A, where such that your A belongs to A. So such that me likhna hai for all values basically. Yes. A comma A for all values. For all values of A belongs. Right? Okay. So let me just check for this. So R is equals to A comma A such that A divides A. And you know what? A divides A is true. Right? This statement is true. A divides A is true for all. For all A belongs to natural numbers. Right? Right? If I take 1 comma 1, so will that 1 divides 1 will be true? Right? If I take so natural numbers na, if I take 2 comma 2, So 2 divides 2 will be true. That means 2 comma 2 will sit inside my relation, right? Okay. If I write 3 divides 3, so A divides A is true for all A belongs to natural number. Therefore, A comma A will sit inside my relation for all values of A belongs to natural number, and hence my relation is reflexive. That's how you need to write, right? That's how you need to write. Reflexive. Okay. Okay. Yes, Hari Varshini, we will get into this. Okay. All right. So this is how we write for a reflexive relation. Now let's talk about symmetric relation. What is symmetric relation? So it is very simple. The moment you see any ordered pair A comma B sitting inside your relation, immediately you will say, okay, if A comma B is sitting inside my relation, then B comma A should also sit inside my relation. Then I call that relation as a symmetric relation. So we have got 3 relations. In the chat box, you need to tell me whether your R1 is symmetric or not. Okay, so 1 comma 1. Symmetricity of 1 comma 1 will be 1 comma 1. So we don't need to check for this. Now 1 comma 2. If 1 comma 2 is there, immediately find 2 comma 1. Okay, it's there. That means we are sorted till now. We are going good. 1 comma 3 is there. Oh my god. 3 comma 1 should also be there. Find it. 3 comma 1 is there. That means R1 is absolutely sorted. It is definitely symmetric. Right? What about R2? 1 comma 1 is there. The symmetric ordered pair will be 1 comma 1. Okay, cool. Till now it is sorted. 1 comma 2 is there. So 2 comma 1 should be there. Okay, so this is there. So this is sorted. Now 1 comma 3 is there. But 3 comma 1 is missing. That's why we can call it as not symmetric relation. Okay. What about R3? So in R3, 1 comma 1 is there. So 1 comma 1 ka symmetry is 1 comma 1. So this is also cool. This is also cool. So this has no issue. This is symmetric relation. Okay. Right? Yes. Perfect. All right. Let me just talk about this particular question which says the relation R is defined on set of straight lines in a plane L1 comma L2 where L1 is perpendicular to L2. We need to check whether this relation is symmetric or not. So, okay. So, how to check whether any relation is symmetric or not? So, basically, definition of symmetric, if A comma B is sitting inside my relation, that means B comma A should also sit inside my relation, and if this is true, then this implies my relation is symmetric. Okay, cool, right? So if L1 is perpendicular to L2, let me just read out the question for you. Relation R is defined on the set A of all straight lines in a R L1 comma L2. L1 is perpendicular. Basically, what they are saying that L1 comma L2, the two straight lines will sit inside my relation R if L1 is perpendicular to L2. So if L1 is perpendicular to L2, that means L1 comma L2 will sit inside my relation R. Okay, all right, yes. And if L1 is perpendicular to L2, likho, that means L1 perpendicular to L2 implies L2 is also perpendicular to L1, right? L2 is perpendicular to L1. If L2 is perpendicular to L1, that means L2 comma L1 will also sit inside my R, right? So that means this and this both together can sit inside my relation R. That means that my relation is symmetric. Okay, all right. Yes, clear? Give me a big thumbs up if you're getting it. You have not liked my session. Why? Why? Everybody has liked my session, no? Chalo, ab transitive. So one student was asking about transitive. So once we are done with transitive, we'll solve one question on equivalence relation and then we will move towards our functions chapter. Okay? Transitive relation. A relation R on set A is said to be transitive if two ordered pairs A A comma B and B comma C is sitting inside my relation, then A comma C should also sit inside my relation, and then we can say that yes, my relation is transitive. So it is little bit trickier than the previous two. Let me just repeat it one more time for you people. If A comma B and B comma C is already sitting inside my relation now, then A comma C should be sitting my relation, so that I can call that relation as a transitive relation. Okay? Okay. So let me just tell you with the help of an example. So we have a set A 1, 2, 3. We have a relation R1, right? So now 1, 1 is there and 1, 2 is there. 1, 1 is there and 1, 2 is there. That means these two, A comma B, B comma C. So now 1, 2 should also be there. So 1, 2 is already there. That means this is sorted. Okay. So first two ordered pairs are sorted. We need to check for every ordered pair. We need to check it very carefully. Now, okay. So I can clearly see 1, 2, 2, 3. Again, a situation like A comma B and B comma C is arriving. So if A comma B, B comma C is there, A comma C should also lie inside my relation. So 1, 3 should be there. And can you see 1, 3 is there? That means yes, 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 my relation is a transitive relation. Oh, my dear students, nice. We are going great. Okay. Yes, tomorrow calculus class again, it will be from scratch. Don't worry about that. Okay, tomorrow 1 p.m. I actually scheduled the class at 1 p.m. because I might take slightly greater time, more time than today's one, because complete calculus 35 marks tomorrow's session. You all know this, right? Okay, all right. Now relation number 2. Tell me whether this is an transitive or not. Okay. So 1, 1 is there. And 1, 3 is there. So 1, 3. Okay, so this is also self-sorted. 1, 1, 1, 3, 1, 3. So it is already there. What about this? 1, 3 and 3, 2 is there. So 1, 2 should also be there. Right? 1, 3 and 3, 2 is there. No? So 1, 2 is missing. 1, 2 is missing. That's why this is non-transitive. Transitive. Okay. What about relation number 3? Now, Harsh, basically there was one student, क्या नाम था उसका? Harsh Verini, something like that. I forgot, please, sorry. है ना? But she or he was asking कि ma'am, if data is insufficient, then it is transitive or not. Okay. So 1, 1, 2, 2, 3, 3 is there. You know what? In this special case of R3, there is no ordered pair like this is getting formed. There is no situation where I can do 1, 1 and so A comma B, B comma C. These two should be similar, right? So 1, 1, 1, something is missing. 2, 2, 2, something is missing. 3, 3, 3, something is missing. Yeah, Hare Varshini, right? So in this case, there are many students who will be doing it wrong. Tell me about this case, whether it is transitive or not. It is transitive or not. So it is transitive, right? So whenever you are out of this particular situation, now this if situation, this if situation is not getting formed, then we cannot check for basically the validation of if condition, right? So we don't need to worry about that. This will be transitive. Okay, this will be transitive. Okay, yes. Getting it? Are you understanding it? Chalo. So now this is the question wherein we need to tell whether this is a transitive or not. So all the ordered pairs will sit inside my relation R if A is greater than B. That means what all ordered pairs can sit? 3, 2, right? 1, 2. And so on. These type of ordered pairs will sit inside my relation, where in the first element should be what? Greater than your second element. How to solve it? How to write it? So in here, how to solve it? So first of all, create a condition that A comma B sits inside my relation and B comma C also sits inside my relation. Now we need to check for A comma C, whether A comma C will sit inside my relation or not. Okay? We need to check for this. Now if A comma B belongs to R, that means A is greater than B. And if B comma C is sitting inside my relation R, that means B is greater than C. Right? Yes. If I combine, if A is greater than B, B is greater than C, it is very obvious. By first and second, we can clearly write that my A is greater than C. And if my A is greater than C, then A comma C will definitely sit inside my relation R. Hence, this is transitive. Hence, it is a transitive relation. Right? Sorry, 1 comma 2, maybe by mistake I have written 2 comma 1 will be there. Okay. So, this is a transitive relation. Right? Okay. Now, for this question, again, we need to check whether the relation is transitive or not. Let me just read it out for you. Check whether the relation R is defined on set of games in a tennis tournament such that R is equals to A comma B, player A defeated player B is transitive. Okay. So, all those basically two players will sit inside my relation where the first player has defeated the second player. So, how do we do that? You know, first thing that A defeated B. This implies A comma B will sit inside my relation. Second, B defeated C. This implies B comma C will sit inside my relation. Now, third thing. If A defeated B and B defeated C, this does not implies if A defeated B and B defeated C, this does not imply that A and C have played any game with each other. Right? So suppose Dhoni defeated Virat and Virat defeated Rohit Sharma. Right? That doesn't mean that Dhoni and Rohit Sharma are playing another game. Right? Yes. So tennis. For tennis, so this is, maybe I've taken the example of cricket, but tennis. Okay, I don't know any tennis player, sorry. Okay? I know one actually. Roger Federer. Okay? But this is how it is. So that doesn't mean that A and C have played any game. If they have not played any game, so who defeated whom is not, we can't say. Okay? So this is not transitive. Not transitive. Right? Okay. All right. So we have another question. Right? Check whether relation R is defined on set A of real numbers so that this is transitive. Right? So in such case, when you have to prove any relation as a transitive, so try thinking when you're not able to prove it. When you're not able to prove it generally, what you can do is create one scenario which will prove this is non-transitive. Let me just show you. So suppose A comma B. Okay. So suppose A is equals to 1 and B is equals to minus half. Right? So 1 plus AB will be equal to 1 minus half. So this is 1 plus AB, 1 minus half. Correct? So this should be greater than 0. Right. Half should be greater than 0. That means 1 comma minus half will sit inside my relation A comma B. Right? Second thing, minus half comma 4. Right? So minus half comma 4, that is So B is equals to minus half and C is equals to 4 you can take, right? And minus half into 4 plus 1, if you calculate it, now it will be what? Minus 1. Minus 1 is still greater than 0. That means minus half comma 4 will sit inside my relation. Okay. So I have taken two cases, 1 comma minus half and minus half comma 4 both sit inside my relation. That means 1 comma 4 should also sit inside my relation. Let me just check for 1 comma 4. So 1 comma 4, that means 1 plus 1 into 4 is what? Greater than 0. Okay. Minus 1 comma maybe, okay. Minus 1 comma half will be the better thing. Okay, let me just write it down. Minus half nahi hai ye. Minus half nahi hai ye. Minus half. Right? Minus half nahi hai. Yes. Yes. So make it minus 1 comma half. So again, so this is half only, greater than 0, and minus 1 comma half comma 4 will be fine. Half comma 4, correct? Right? So half comma 4 or maybe minus 4, right? Half comma minus 4, better. Half comma minus 4. Half comma minus 4, right? Half comma 4. So it is greater than 0. 1 plus, yes, is greater than 0. So it is 2. Plus 3 is greater than 0, right? Half comma plus 4. Make it as plus 4 only. So now 1 comma 4 belongs to R. It is minus 1, right? So this is minus 1. So can you see minus 3 greater than 0? This does not belong to R. Let me just recreate the example one more time. So minus 1 comma half, is it satisfying? Let me just check. So 1 minus half into 1 greater than 0. So it is satisfying actually. Half comma what? Plus 4. So half comma plus 4 will be what? 1 plus half into 4. So it will be 3. 3 is greater than 0. It is satisfying. So basically minus 1 comma half and half comma 4 both are satisfying. So that means minus 1 comma 4 should also sit inside my relation, right? Minus 1 comma 4. But if I actually write minus 1 into 4, this will become negative, which is not positive. So it is not sitting inside my relation. Hence it is non-transitive. So what did we learn from this particular example? So in previous example, you can clearly see that we can generalize this. It is very obvious to prove this from equations, right? But in this example, proving from equations is not at all a easier task, right? So what we do, we actually think about one such case which will prove that it is not transitive, right? Okay. Yes, minus 1 is less than 0. Yes, yes, yes. So kya hua? But minus 1 comma half is satisfying this or not? Tell me. The moment I put minus 1 into half, tell me. So 1 minus half, that means half is positive. So it is satisfying, right? Yes. Hai na, Santosh? Also about this half comma plus 4. The moment you put half and 4, na, it is satisfying this inequality. So both ordered pairs are satisfying, but this ordered pair is not satisfying because overall if you calculate 1 minus 4, so minus 3 is becoming negative. It is non-transitive. Right? Is that clear now? Okay. All right. Now we have studied. Okay. All right. I guess it is fine now. Okay. Now equivalence relation. Now we have studied what? Reflexive, symmetric, transitive. So all the relations which are all three, that is reflexive, symmetric and transitive. So you know the definition of reflexive, a comma a for all values of a belongs to a. Reflexive. Symmetric is a comma b is there, so b comma a should be there. And transitive, a comma b comma c is there, so a comma c should also be there, right? Yes. Identity relation is an equivalence relation, right? Why identity relation? Suppose a is what? 1 comma 2 comma 3. Tell me. R1 is 1 comma 1, 2 comma 2, 3 comma 3. Absolutely, this is reflexive. Identity relation is reflexive, that I agree. Symmetric, yes, obviously, because 1, 1 ka symmetric is 1, 1, 2, 2 ka 2, 2, 3, 3 ka 3, 3, right? Transitive, yes, definitely, because we don't have any such situation to check for the third pair. So that's why this is equivalence, reflexive, symmetric, transitive. Now we have a question from your NCERT only. How do you write it in your examination? I'll show you. Let T be the set of all triangles in a plane with our relation given by T1, T2 will sit inside my relation if both the triangles T1 and T2 are congruent. So basically they are saying T1 is congruent to T2, right? T1 is congruent to T2, so we need to show that this is an equivalence relation, okay? For reflexive, okay, reflexive के लिए we already have condition. नहीं, equivalence show करना ना. For a relation to be, so you have to write, for a relation to be equivalent relation, it has to be reflexive, symmetric and transitive. So first thing we need to prove it as a reflexive relation. So for a reflexive relation, R is equal to A comma A such that, नहीं actually such that नहीं, for all values. For all values of A belongs to capital A, right? So now T1 comma T1 will belong to R as T1 will be congruent to itself, right? Each and every triangle is congruent to itself, or you can write as each triangle is congruent to itself. It is better to write each triangle is congruent to itself. Each triangle is congruent to itself. Each triangle is congruent to itself. So hence T1 comma T1 will sit inside my relation R for all values of T1 belongs to which set? T set. T be the set, no? T is the set. Okay. All right. So hence it is a reflexive relation. So we have proved this reflexive relation. What about symmetric? So for symmetric, if T1 comma T2 sit inside your relation R, that means your T1 is congruent to T2. And if T1 is congruent to T2, T2 will be congruent to T1, right? T2 will be congruent to T2. So that means T2 comma T1 will sit inside my relation. Hence this is symmetric relation, right? What about transitive? What about transitive? If T1 comma T2 comma T2 comma T3 belongs to my relation, this implies T1 comma T3 will belong to my relation. Reason क्या होगा? T1 and T2 are congruent. T2 and T3 are congruent. This implies T1 and T3 are also congruent. Hence, T1 comma T3 will sit inside my relation, and this is a transitive relation, right? Yes, so it is a transitive. So if a relation, now you have to write the whole statement. So now this relation is a symmetric, reflexive as well as transitive. Hence it is an equivalence relation. Write it properly so that you will get full marks. Okay, so we have a question for in front of us. All right, so these type of question may come in your upcoming board examination, right? Let me just open the chat box. Yes. Next question. Show that the relation S in the set A is given by A comma B. A comma B belongs to Z. A minus B is divisible by 3 is an equivalence relation. So first of all, we need to prove that this is an equivalence relation, right? Okay. Set A is what? Tell me. What is your set A? So set A is 0, 1, 2 because all elements are integers. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Okay. Now, if I want to prove that my relation, that's how you need to write. Please, I know that by looking at it, you're like, okay, ma'am, reflexive, symmetric, transitive, but this is not your JEE main paper. This is your board paper. So listen the step-by-step process of this. A is given to you, right? Now, your relation will be reflexive. Will be reflexive. If 0, 0, 1, 1, 2, 2 से लेके end तक 12, 12 will sit inside your relation. All the ordered pairs. So we need to prove that yes, all my ordered pairs are there. So case first thing 0, 0 sit inside my relation. So for 0, 0 sit inside my relation, mod of 0 minus 0 is divisible by, should be divisible by 3. Right? Yes. Yes. 0 is divisible by 3. So that means 0, 0 will sit inside my relation. Okay. Now similarly, that's how you can write similarly three parallel lines ly. Right? Similarly, 1, 1 sit inside my relation. That means 1 minus 1 is also divisible by 3. Same thing. Okay, so 1 minus 1, 0 is divisible by 3. That means yes, 1, 1 is divisible, right? And similarly, all other, so 2 ordered pairs, not similarly. So now, similarly, 2, 2, 3, 3, se leke 12, 12 will sit inside my relation because, let's say, A minus A is divisible by 3. Right? So we have proved that this relation is reflexive. Okay, all right. Now second. So this relation is reflexive. Let me just add one PPT. Keep. Insert new slide. Okay. Blank. Duplicate, slideshow from current slide. Okay. Yes. Now for symmetric. Yes, all are divisible by 5. Right? For symmetric. Yes. For symmetric, what we need to do is, okay, so suppose A comma B, right? A comma B for integer, right? So what all ordered pairs will be there in my relation? Tell me what all ordered pair will be there. So, for symmetric, okay, so if A comma B belongs to my relation, this implies B comma A belongs to my relation, right? Yes. So if A comma B belongs to relation, that means A minus B is divisible by 3. That means that B minus A is also divisible by 3. Hence B comma A will sit inside my relation. This is symmetric. Okay. All right. Right. Yes. Clear? Okay. Now transitive. So case 1, A comma B belongs to my relation. Second, B comma C belongs to my relation. Right? Okay. And so that means what? That A minus B is equals to K. You can write it this way, right? So A minus B ka mod is divisible by 3K1. B minus C ka mod is divisible by 3K2. Okay. So now A minus B is either 3K1 or minus 3K1. Okay. B minus C is equals to 3K2 or minus 3K2. Okay. In any case, if you add, A minus C will be equal to 3 times K1 plus K2 or K1 minus K2 or 3 times K1 minus K2 or 3 times K2 minus K1 or 3 times K1 plus K2 with a negative sign. In all the cases, A minus C is multiple of 3, right? So that means A comma C will sit inside my relation. That's how you need to write it down. Okay? Yes? A comma B will sit inside my relation. That means A minus B is multiple of 3 mod of A minus B. That means A minus B either plus or minus 3K1. B comma C same 3K2 plus or minus. Now if I add these two, B and B are getting cancelled out. So A minus C, if both are positive, K1 plus K2 3 times. If both are negative, minus of 3K1 plus K2. If one is positive, one is negative, K1 minus K2 and minus K1 plus K2. Can you see this? Or in all the values, can you see everything is multiple of 3? So A minus C is definitely a multiple of 3. So A comma C belongs to R. So this is symmetric, transitive and reflexive as well. Hence, this is an equivalence relation. Okay. So now we have finished. Yes. Now we have finished the relations part. Let's just move on to the functions part. Okay. Let's just move on to the functions part. Correct. So function. A function is a relation. Yes. A function is a relation, but with two conditions. Listen to me carefully. So a function is a relation defined from set A to set B such that each and every element of set A is uniquely related to an element of set B. So first condition, so I can clearly see that it is a kind of relation, but there is a condition that from set A, each element should be connected. From set A, can you see? From set A, each and every element should be connected. Okay. So suppose we have this. Okay. So from set A, can you see? Each and every element is connected. A, B, C, all three are connected. But there is no such condition in set B. You can clearly see. Why? Because 3 is left out. But in set A, we cannot leave anything. If it is a function, right? Okay. And is uniquely related to element of set B. That means that from set A, we cannot have two images, right? It can't be like this, that A is having 2, A is having 3. No, not happening. So unique image should be there. If I ask you what is the image of A, you will be able to tell me only one image. Okay. All right. Okay. So two things you need to check basically to prove that this relation is a function or not. This is not a function. Can you see? So first check you have to do over here is whether A, B, C, all three are connected. So yes, A is connected, B is connected, C is connected. But can you see A is connected to two elements. So the image of A is not unique. So this is not a function, right? This is not at all a function. Okay. All right. So it is denoted by F such that A to B, where A is nothing but domain and B is nothing but codomain. Please do not get confused with range. This set B is nothing but codomain, right? So suppose this is your function. Can you see A is connected to 2, B is connected to 4, C is connected to C. So this is a function. Yes, this is definitely a function. Why? Because can you see A, B, C all are occupied. First condition is getting satisfied. And if I ask what is the value of A, the image of A, so you'll say 1 value 2. Image of B 4, image of C 1. So that means sorted. So from set A, each are having unique image. What about this? So again, A is connected, B is also connected, but C is also connected. But if I see A is connected to two different elements. So if I ask you image of A, you will say 2 and 3. So this is not a function. Right? Not a function. Okay, what about this? So A is connected to 2, B is connected to 3, C is not connected to anyone. That means again not a function. Not a function, right? Okay. All right, domain and range and codomain are three different things. Okay, so over here domain is the complete set A. So A, B, C is the domain of this function. This is not at all a function. This is also not at all a function. But complete set A will be domain. Okay, because everything is connected. So we have to write it in domain. What about range? So in range, all the value of F, basically set B which are connected. So in this case, what is the range? 1, 2 and 4 is the range. Right? So range will be what? 1, 2 and 4, because 3 is not connected now, so we cannot write 3 in the range. But codomain is what? Set of all elements in set B. So this will be 1, 2, 3, 4. Are you getting my point? All 4 values. So can you see that ranges will always be either less than or equal to codomain? So we can say range is subset of codomain, right? Range is either equal to or subset of codomain. All right. Okay. So now there are two classifications which are given in your NCERT booklet. First classification is given as 1-1 function. It is also called as injective function or injective mapping. Please listen to this carefully. Okay. A 1-1 function is said to be 1-1 function if different elements of set A have different F images in B. If different element of set A have different images in set B. Let me just show you. So over here, yes. So can you see that first of all it has to be a function. So all three are occupied, sorted. So 1, 2, 1. Can you see 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 1, like this. Okay, right? So no two elements will have a single mapping. That's how it is going to be, right? So this is a 1-1 function, right? So basically, you will be asking me, ma'am, what is many one then? Let me just show you the many one function first. So many one function, how does a many one function look like? So many one, can you see? Two different basically values in domain have single output. It is many one. That's how you do it. Many one, many to one, right? What about this? So can you see that many to one, right? This is your many one function, and 1-1 is what you all know, right? 1-1 is what you all know, right? Now how to, so this is very important. Now this is something which is actually important. So how to prove or how to know whether a given function is 1-1 function. So suppose you are given with two functions, 3x plus 5 and fx is equals to x square. Obviously for JEE we have a shortcut method, but for CBSE boards we have to follow a procedure. So I'll show you. So basically we need to check whether my function is 1-1 or not. Okay, how to check it? So first of all, what I'll be doing is so this is the method of converse. Method of converse say that I assume deliberately that there are two values x1 and x2 which are mapping to one value y, right? F of x1 and f of x2 are mapping to one value y. So this will be a many one function, right? So that's how we are going to do. So basically what we are doing is x1 and x2 are two different values, right? And f of x1, this value, this is f of x1 and this is f of x2. F of x1 and f of x2 both will be same, both will be equal. Now both we need to equate it. If it gives me that x1 and x2 are equal, right, that means that my function is 1-1. If it doesn't give, that means my function is many one. Let me just show you once. Let me just show you. Okay. So what I'm trying to say is, okay. So let me just take x1 and x2. x1 and x2 belongs to domain of your function, right? Now f of x1 is equals to f of x2, right? We need to equate these two values. So on two values, f of x1 and f of x2, we need to equate it. The moment I equate it now, it will give me whether both values are actually equal. It can be equal or it cannot be equal. I am checking the validity of this equality. So f of x1 will be 3x1 plus 5. F of x2 would be 3x2 plus 5. 5 and 5 are getting cancelled out. 3 getting cancelled out. x1 is coming out as x2. That means it is trying to make you understand that the scenario you have created in your head, na, ki there will be two different values which will be mapped to single value, is wrong. No two different value exist. In fact, x1 and x2 are one thing. So 1-to-1 mapping is there. So this is a 1-1 function. This is a 1-1 function. So basically solving for 1-1 and many-1, the process is exactly same. I'll show you x square, right? So x1 comma x2 belongs to domain of this function. Domain is R. So f of x1 should be equal to f of x2, right? So x1 ka square is equals to x2 ka square, right? Now shift this to the left hand side. x1 ka square minus x2 ka square is equals to 0. Solve it nicely, carefully. A square minus b square. A plus b and a minus b is equals to 0. So first thing is x1 is equals to x2. So this to we know. But second thing, can you see this is 0. x1 is equals to minus x2. That means there exist some values. So suppose 1 pe it is giving me 1, minus 1 pe also it is giving me 1. So it is clearly a many one function. And you can write it down this as well. F of minus 1 is 1, f of 1 is 1. So minus 1 and 1, both values are giving me 1 as an answer. So this is a many one function, right? That's how we solve it. Good question, nice question, right? Okay. Yes. So this is a many one function which I already told you that many to 1. So two different value are giving you one output. Two different input are giving you one output. So you all know that how to identify a many one function. Same process. Can you see this? Okay. So x1 comma x2. Both value belongs to domain. F of x1 is equals to f of x2. That means what? x1 square plus x1 plus 2 is equals to x2 square plus x2 plus 2. 2 and 2 are getting cancelled out. Shift everything towards left hand side. x1 square minus x2 square. Okay, plus x1 minus x2 is equals to 0. Again, x1 minus x2, x1 plus x2 plus x1 minus x2 is equals to 0. Can you see? Take common x1 minus x2 and inside it you will be getting x1 plus x2 plus 1 is equals to 0. What does that mean? First thing which is coming over here is x1 minus x2 is 0. This implies x1 is equals to x2. That too we know. But second thing is there which is x1 plus x2 plus 1 is equals to 0. That means x1 is equals to minus of 1 plus x2. This implies that this is a many one function. And you know what? Quadratic equations, quadratic expressions are many one functions, right? In the domain, in the general domain, not the cut short specific domain. All right. So you have 1-1, you have many one. Okay. Then you have onto function. Now what is onto function? So basically 1-1 and many one are the property of domain. But onto function is something which is property of codomain, right? So basically what they say is the complete set B should be connected. There is no element in set B also which should be left out. If it is the case, you will call it onto or surjective mapping. Okay. So basically from A to B such that each and every element in set B must have at least one connection. Okay. All right. That means set B, the complete set B is connected in some way or the other. That means complete set B will be the range and codomain this time in here is nothing but, yes, The function which is not 1, 1 will be many 1. A function can either be 1, 1 or many 1. Right? If it is not 1, 1, it is many 1. If it is not many 1, it is 1, 1. Right? Like that. Okay, so onto function, right? You know, so each and every element of set B should have at least one pre-image. Right? That's how we call it as a basically many 1 function. Right? So suppose we have this set A 1, 2. Set B A, B. Function जो है is such that 1, A and 2, A. Tell me whether it is a onto function or not. This is your F1. Function 2 will have 1, A. Okay. And 2, B. What about this? So this basically, can you see range is having only A and codomain is A, B. So range is not equal to codomain. That means this is not an onto function, not an onto function, not onto, not surjective you can say. But A and B both are here. So this is definitely an onto function because range and codomain both are equal. Are you getting my point? Range and codomain are equal. Then we can say that yes, my function is onto. Okay. So now a function is 1, 1, many 1, onto, surjective, that means, or not onto, right? Now a function which is 1, 1 also and onto also, that means injective also and surjective also. Injective, surjective, that means both ejective. 1, 1 is also there, onto is also there, so we can call it as a bijective function, right? So this will be bijective function. Onto function, yes. So onto function is nothing but, so you all know what is a function, right? For a function, set A, all elements in set A should be connected. If any one element in set A is left out, we will not call it as a function. But in set B, elements can be left out. I will show you that we have got some scenarios where some elements in set B is left out. Okay. So can you see when we were studying the function, can you see 3 is left out? But still this is a function, right? But in here, can you see C left out? Now this is not a function. That means every element of set A should be connected for this to be a function. What about onto function? For a function to be an onto function, it has to be function. That means all elements of set A should be connected. But specifically for onto function now, specifically for onto function, we cannot have any element in set B which is not connected. No left out element should be there in set B. That's what I'm saying for an onto function. And set A though it should be there, all elements. So basically for an onto function now, set A, set B, no element should be left out, in short, right? So every element in set B should be connected to some way or the other. Right? Clear? Yes. Who was saying repeat film roll? Please show me a big thumbs up that okay ma'am, understood now. We will do some problem. Do not worry about that. We will solve problems on this. Okay. All right. So let me just take some problems. Okay. Some important problems I have I have with me. Give me a moment. Right. Okay. So the question is, show that the function f. Now from here we are doing some functions, some questions which are PYQ, or you can expect in your board exam. These kind of question can come in your board exam. Show that a function f in A to R minus 2/3. Okay? Defined as f of x is equals to 4x plus 3 upon 6x minus 4 is 1, 1 and onto. Okay, we need to show that this function whose domain is A and codomain is R minus 2/3 is 1, 1 and onto. So first of all, we need to show whether the function is 1, 1. So for 1, 1, what do? We have a method x1 comma x2 belongs to set A, which is domain, right? This time set A. So f of x1 should be equal to f of x2. Write it with me, okay? So 4x1 plus 3 upon 6x1 minus 4 is equals to 4x2 plus 3, 6x2 minus 4. Cross multiply. Let's do it. 6 4s are 24, x1, x2. 4x1 minus 4, so 16x1. 6 3s are plus 18, x2 minus 12 is equal to, now can you see again, 24 x1 x2, right? Then we have 18 x1, right? 18 x1. Then we have minus 16 x2 and we have minus 12. Minus 12 clearly gone. 24 x1 x2, 24 x1 x2 clearly gone, right? So the 16 x1, 18 x1, so this will become what? Tell me. And 16 x2, so this is giving me actually x1 is equals to x2. The moment you solve it, x1 is equals to x2, this implies this is my 1, 1 function, hence proved. Right, so this is my 1, 1 function. Okay? Can onto function be either 1, 1 or many 1? Yes. Yes, Jay. Absolutely. Yes. Onto function can either be 1, 1 or many 1. So basically, it's not there in your NCERT, but it's there in your JEE that there are 4 classifications, 1, 1 and onto. Bijective, that is there in your NCERT. Then 1, 1 and into is also there. Then many 1 and onto, many 1 and into. Right? So 4 classifications are there. Now, onto. For onto, what we need to do is, for onto, every time you have to figure out the range of this. To figure out range of any rational function, linear by linear, you have to do this. Y is equals to 4x plus 3, 6x minus 4, cross multiply this time and find out the value of x completely in terms of y. Do that. So it will be what? 6xy minus 4y is equals to 4x plus 3. Right? So this will be 6y minus 4 times x is equals to 3 plus 4y. X is coming out as 3 plus 4y upon 6y minus 4. Now range will be calculated by denominator. So denominator cannot be equal to 0. That means 6y minus 4 cannot be equal to 0. Y cannot be equal to 4 by 6. That means 2 by 3. So y cannot be equal to 2 by 3. So range of this function is coming out as, tell me, range will be what? All real values except 2 by 3. What is the codomain? This is your codomain. Right? This is your range. Can you see the exact similarity between codomain and range? So you have to write in this particular function, clearly my codomain and range are equal. Hence my function is onto. So my function is 1, 1 as well as an onto function. Have a look how to write it and understand. Okay? Alright. In the chat box, please confirm so that I will move on to my next problem. Shall I move on to my next problem? Yes. Next question. Okay. So the question says your set A. These type of question will be there in your board examination. Set A is R minus 2. And you have another set which is set B, R minus 1. Okay. All right. And you have set C also, which is okay. Nay, if your function f is defined from A to B in such a way that f of x is equals to what? Fx is x minus 1 upon x minus 2. You have to check. Show that your function is 1, 1 and onto. Show that function is 1, 1. Same procedure and onto. 1, 1 and onto. All right. Yes. So again, same thing. For 1, 1, you know what to do. F of x1 is equals to f of x2. x1 minus 1 upon x1 minus 2. x2 minus 1 upon x2 minus 2. Cross multiply. x1 x2 minus 2 x1, ठीक है, minus x2 plus 2 is equals to x1 x2 minus 2 x2 minus x1 plus 2 plus 2 plus 2 cancel, x1 x2 cancel, right? So you will be getting what? 2x1 if you shift it towards right side, 2x1 minus x1 will be x1 and here x2. So this is definitely 1, 1 function. Okay. What about onto function? So you know same thing, x minus 1 upon x minus 2. So you need to calculate the range and it should match with this. Okay. So yx minus 2y is equals to x minus 1. Collect x wali terms together. So y minus 1 times x is equals to 2y minus 1. X is coming out as 2y minus 1, y minus 1. And in here, denominator cannot be equals to 0, y cannot be equal to 1. So range is coming out as, tell me in the chat box, r minus 1, which is equals to codomain. Hence my function is onto, or you can call it as surjective. ठीक है? All right. Okay. So now I have one more topic to teach, which is composition of functions. Composition of function. ठीक है? Composition of function. All right. So composition of function means that you have a function which is defined from A to B. You have another function which is defined from B to C. Then you will have a function fog which is defined from A to C, right? And yes, fog is A to C. So let me show through the help of your mapping diagram. Okay. So you have A, you have B, you have C. So in here you will put X, right? And you will get what? F. So this will be f of x. Okay. So f of x you will put in g of. So you will feed f of x to your next function g. It will become g of f of x, right? So this will be what? Yes. So this is g. From here to here, you will be getting your GOF. Sorry. A to C, right? Yes, so this is G of F. Yes, this is GOF. So this is G of F, absolutely right, okay? So this is how your diagram will look like. So this is your G of F of X. This is your F of X, right? And this is your X. Right? GOF, right? Because you are feeding f to your g function, na? That's why f will be inside your g. Okay? You can create your fog as well. For fog, the middle function should be g of x. So g of x should act as an input in your next function. Right? So right now fx is becoming input. Can you see x is input? So it will go inside your f. And this time fx is the input. So it will go inside your g, right? That's why it is g of f of x, not this, okay? So that's how it is. F, then we g, GOF, all right? Yes. So GOF x is equals to g of f of x. Shall I do a question on composition of function? Yes. Okay. Yes. Daily live classes. Tomorrow we have a live class at 1 p.m. Why 1 p.m.? Because we have a whole calculus to do. So tomorrow's class will be a little bigger, lengthier class. So have your breakfast nicely and then come. Okay. All right. Chalo. We have a question. We have a question. All right. Yes. For composition, one question. Composition function deleted bol rahe ho? No, it's there in your new NCERT. Composition function is there. Okay. Basics are there. I am doing all the things from new NCERT. All right. So we have a question. Show that. ठीक है. Show that f r minus 2. Okay. And then we have r minus 1. Defined by fx is equals to x upon x minus 2. Okay. Then we have another function also. G. We have g r minus 1, r minus 2. Yes. R minus 1, r minus 2. Defined by g of x is 2x upon x minus 1. Find g of x. Yes. Is 1, 1. Okay. So the question is asking you, we are almost done. 5 minutes more, we will be done with this session. Okay, show that this function defined by fx is equal to x upon x minus 2 is 1, 1. So we need to first show that my function fx is 1, 1. So fx is 1, 1, you all know how to do that. Okay, 1, 1. So x1 comma x2 belongs to domain of f. है ना? F of x1, let it equal to f of x2, right? And yes, x1 upon x1 minus 2, x2 upon x2 minus 2. If you solve it, you will get x1 is equals to x2. You will call it as a 1, 1 function. Now you have to find g of x. G of x will be g of f of x. How to calculate g of f of x? Listen to me nicely. You have g of x. So whenever you have to calculate composite function, always refer to the outside function. Here outside function is g. So always refer to this. And in here, please replace in this box, wherever you find x, replace x by f of x. So g of f of x will be equals to 2f of x upon f of x minus 1. Now plug in the value of fx. Fx is x upon x minus 2. 2x upon x minus 2, right? 2 times fx upon fx minus 1. So x upon x minus 2 minus 1. If you solve it, what would you get? So 2x upon x minus 2, g of f of x is coming out as 2x upon x minus 2 upon LCM x minus x plus 2 upon x minus 2. Right, so this is gone, x gone, 2 gone, it is coming out as x. Okay, g of f of x is coming out as what? X, right? Easy peasy, right? Okay, call, clear? Okay, all right. So now we have one more topic left. Let me just show you. And the topic is invertible function. Invertible function. Right, invertible function. So suppose we have a function defined from x to y. If x to y, if f is a11, add on to function. That means the function is injective as well as surjective, or you can call this function as bijective function. Then there exists a function a function g which is equals to f inverse. there exists another function g, right? So suppose a function is there, x to y is 1, 1, and onto there exists a function g, y to x, or we can call it as f inverse y to x, which is inverse of a function inverse of x, f, and it is also given that when it happens, f of g of x is equals to g of f of x is equals to x. Okay, all right, let me just explain you. If a function is 1, 1 and onto, or we can call it as injective as well as surjective, or we can call it as bijective. For a bijective function, there exists an inverse function in such a way that you can see x to y, so y to x. In here, codomain and domain have been interchanged. Can you see this? Codomain and domain, or you can call it as range and domain, because codomain and range both are same thing. So call it codomain, call it range, no problem. So in here, range and domain both got interchanged. So this is what your domain, right? This is your range, or you can call it as codomain as well. So both will get interchanged. So now this, for f inverse, this will be your domain and this will be your range, or you can call it as codomain of the inverse function, right? Okay. So which type of question can be there in your board examination, right? Let me just write it down. Okay, so let me just add. Okay, let me just write down one question. So you have a function f. Let f is such that n to y, natural number to y, okay, be a function defined as fx is equals to 4x plus 3. Okay, where y is equals to capital N, such that y is equals to 4x plus 3. For some x belongs to n, show that function is invertible. X belongs to n. Show that function is invertible. So we need to show that my function is what? Invertible. Right? So they will not write specifically show that the function is 1, 1 and onto. They will not write specifically show that the function is bijective. Neither they will write that the function is show that the function is injective as well as surjective. They will write show that your function is invertible. Right? So same thing. You have to prove that my function is 1, 1. How do you prove it? You all know that. Okay. So basically 4x1 plus 3 is equals to 4x2 plus 3. This will give you x1 is equals to x2. Write it nicely. So 1, 1 proving is absolutely easy. What about onto? Right? So we need to prove that my function is what? Onto. Okay. So what is y? So for onto, range should be equal to codomain. Right? And where is my codomain? This y set is my codomain. So my range should be equal to y. What is y? It is given that y belongs to natural number, right? For some, okay. So y, actually this y is nothing but the moment you put all the values. So calculate y. Sabse pehle calculate y. So y will be what? The moment you put x is equals to 1, you get y is equals to 4 to the 8, 9, 10, 11. So 11 will be there. 4 to the 8, 9, 11. Right? Then the moment you put x is equals to 2, so 4 to the 8. Okay, sorry. 4 plus 3, 7, 11. And so on. This will be your capital Y. And now what is the range? For range also you will be calculating the same way. So now range is, if you calculate range, it will be also 7, 11 and so on. So you can clearly say that range and codomain are equal. Hence, my function is 1, 1 and onto, which is called as a bijective function, which is also called as an invertible function. Hence, my function is invertible. Okay? All right? Clear? Okay. Last one question I would like to do. Actually, last question. Okay. So give me like 2 minutes, because I have a feeling, and you know my feeling, right? I have a last question feeling that this type of question may be there in your board examinations. Okay? You know my feeling, right? Whenever I feel there are high chances that that type of question comes in your examination. Okay? All right. Yes. Last question. Prove that the function is 1, 1 but not onto. Okay. So prove that function is what? N to N is 1, 1 but not onto. 1, 1 but not onto. N to N. Now 1, 1. For 1, 1, so you know how to do it. 1, 1 ke liye I am telling you, but this is something new, but not onto, not onto. So not onto is something new for us. How to do not onto? What is the function? Y is equals to x square plus x plus 1. This is your function. So 1, 1, you will be able to do it. Okay, let me just show you 1, 1 as well, because this is a quadratic expression. So f of x1 is equals to f of x2. Okay, let me just prove it 1, 1. x1 square plus x1 plus 1 is equals to x2 square plus x2 plus 1. 1 and 1 are getting cancelled out. So x1 minus x2, x1 plus x2. And a plus x1 minus x2 is equals to 0. So x1 minus x2 is cancelled out. So x1 plus x2 plus 1 is equals to 0. Right? So this cannot be true. Now you will be telling me, okay ma'am, this is coming ma'am, this is not 1, 1 function. What are you saying? No, no, no. So basically, you have to show that if your x1 belongs to natural number, no, x2 doesn't belong to natural number. If you put 1, your x2 will be what? Minus 2. Right? If you put 2, so x2 will be negative. For x1 to be natural number, x2 is becoming negative, so which is not possible. This is not possible, because can you see natural number is there? You only can put natural number, and you only can get natural number, right? So that's why this is not possible, right? So this is a 1, 1 function. This is accepted, but this is not accepted. Okay, this is one thing. Okay, all right. So this type of question. Okay, I'm not onto. For onto, now you have to put x is equals to 1, x is equals to 2, x is equals to 3 and get value of y. So 1 plus 1 plus 1, 3. Can you see 4, 5, 6, 7? Y is equals to 9, 10, 11, 12, 13, 13. So can you see that you are not getting, we are not getting y is equals to, y is never 2, y is never 4, right? We are not able to get 1 as well. 1, 2, 4, 5, 6. That means that your codomain is not equal to range, right? Because in your codomain, 1 is there, 2 is there, 3 is there, 4 is there. But you know what? In your range, you're not getting every natural number. You are getting a very few natural numbers. What does that mean? That your range is not equal to your codomain, but a proper subset of your codomain, hence not onto. Abhi ek student is saying ki how to write in the exam, so that's how you write. Let me just show you nicely. I know I have created a mess. Okay? Yes. So that's how you write in your examination. So basically f n to n and f of x is x square plus x plus 1. Show that your function is 1, 1 but not onto. ठीक है, तो for 1 1 तो you have to do same thing. F of x1 is equals to f of x2 and x1 square plus x1 plus 1 is equals to x2 square plus x2 plus 1, right? So cancel, cancel. The moment you solve it, x1 will be equal to x2 or x1 plus x2 plus 1 is equals to 0. For here, x1 belongs to natural number, x2 will become negative. Negative. And x2, you can write down like this. x2 does not belong to natural number. x2, for any x1 belongs to natural number, x2 does not belong to my natural number. Hence, this condition is not true. And this condition is true. Okay, so we can call it as a 1 1 function. Okay, this is 1 1. For onto, what you need to do is you need to put only x is equals to 1, 2 and 3. So y will be what? 3, y will be 4, 5, 6, 7, y will be 13. So you are not, basically your range, if you write down your range, no, it will be 3, 7, 13 and so on, right? Okay, so clearly codomain is what? 1, 2, 3. Codomain is not equal to range and this is not onto. That's how you write it in your exam. Okay? Got it, Tanisha? Yes? All right? Okay. So this was all about relations and functions, and I have already told you in yesterday's session that you have to finish your NCERT nicely. You have to NCERT exemplar in case you get time. Right? In case if I get time, no, I will be sharing most important questions from exemplar as well. Right? And yes, along with that, yes, what else? PYQ and mock test. Okay. All right. So now we are giving free mock test, right? For class 12th. Can you see? For your board examination, and it is computer based mode, and it is absolutely based on boards ka new syllabus. Can you see? This is absolutely free, and you know what, link is given in the description box, so you just can click on the link and enjoy your giving the mock test, right? So yes, if I content J, no, J ke liye it is a little bit less content, right? So I'll be teaching for specifically J as well, but this is like a portion of J has been completed because functions is very huge for your J, but for boards it is not that great. Okay, all right, Shruti, I hope this explain. So this will cover your boards, but this will not cover entire J thing. I will be taking sessions for J as well in detail. Do not worry about that. Okay. All right, so I'll see you tomorrow 1 p.m. sharp. You know what you have to do. Finish your lunch or brunch and then come, because the session calculus may take a little longer, right? So this is Namrata signing off.